Wow. Wow. Another beautiful day. Fish are swimming. Birds are chirping. Everything is balanced. No, not for long. I just arrived. Who are you? That's the thing. I could be oil from a parking lot, fertilizer from a lawn, smoke from a factory, trash from the street, or chemicals from a pipe. Oh, so you're pollution? Not exactly. I'm the result. The real question is, where did I come from? So today we're not just learning about pollution, we're learning about its sources. Exactly. Follow the trail, find the source. All right, first video of Unit 8. This is aquatic and terrestrial pollution. So we're going to learn all about how our land and waters get polluted. So 8.1, sources of pollution. Where does this pollution come from? I've touched on a lot of this before, but we'll get into the details more specific. So one thing I've mentioned before is this idea of point pollution, point source, and non-point pollution. So this first, we'll first talk about point source. That's where you have a single identifiable source, like you see smokestacks, or you have an outfall pipe from, say, roads, neighborhoods, or a factory. So such as a smokestack. Let's write that in. A waste discharge pipe. Now, I don't know exactly where this pipe is coming from, but I mentioned to you earlier, we did see a map of air pollution where there was a lot of sulfur dioxide pollution, acid rain in the American Southwest. And this could be a reason. This is a coal-fired power plant in Page, Arizona. Coal-fired power plant. So this was shut down, I believe it's 2021. So in 2021, that was horrible handwriting. 2021, it was closed. Okay, and these smokestacks were demolished a couple of years ago, I believe. And remember, we used to have more of some coal-burning, coal-fired power plants out west, but it has been really phased out. This is one of those examples. So you can go to one specific place and deal with it, either handle the pollution coming out of this pipe, or put scrubbers that we talked about in Unit 7, before the exhaust escapes into the air. The next idea is non-point sources. And this is much more difficult to deal with because it's just coming from everywhere, it seems like. So one of these possible sources would be pesticide spraying. So that's what we see here. These are all pesticides. These could be fertilizers too. It's very hard to tell, but they're spraying something, and it's kind of going everywhere. There's probably a drainage ditch over here and over there we can see, and it goes into the air. This is just going to go everywhere. And it's going to be hard to really prevent a lot of that. And so this would be from agricultural, rural areas. We often think of rural areas being clean and perfect, but it's really not the case with most when agriculture is involved with rural areas. We are pretty, we think of urban areas, we do kind of expect a certain amount of pollution, right? We're living in a city, so many people around. So we definitely will see examples of this pollution coming from, city streets, housing, garbage that people throw out. That cup that doesn't quite make it in the garbage can make it into the rivers, lakes, and streams of the area that you live in. So here are some ideas. We have non-point solutions to runoff from rooftops, runoff from driveways. Now, up on the roof, you could have a lot of, soot, from atmospheric fallout from the exhaust from planes flying overhead. Other sorts of, industrial processes, exhaust going up and then coming back down. What goes up must come down, and it will land on the roof, and that will drain off of it during storms whenever it's wet. Driveways, we park cars on driveways. That's going to be, there's going to be oil, brake dust on there. Like when I wash my car and I spray the wheels, I just see all this gunk coming off from the inside from all the brakes, and that's not good stuff. It's better than it used to be, but still not super positive. Then runoff from lawns. Let me see. This one down here, streets. So anything that gets in the streets, which is more oil, brake dust. And then lawns, you might have fertilizers, pesticides there. People put a lot of things on their lawn, okay, to try and keep the grass green, keep the pests down, keep the flea population down, and then write down these pet waste, dog poop we see everywhere, leaves, fertilizers, motor oil, detergents, soaps, and other sorts of cleaning agents, and that can just go in the street. But check this out: when it comes out of a pipe, that means it's a point source. Whatever comes out of a pipe, we consider that point source. These large air, but where does it come from exactly? That's non-point. It's kind of confusing. Okay, this is all over the place, but we can kind of dial down that one spot. This is a diagram of all the storm drains in LA County. And it's pretty cool. They mostly follow the natural streams and rivers we have. We can see the LA River coming through here, the Rio Hondo coming through here, Compton Creek coming right here, Dominguez Channel coming this way. If you were on the 405, you'll see that. San Gabriel River, where the 605 is, comes all the way down here. Coyote Creek right here. So all through these neighborhoods, you just have all these little drains, above ground or below ground. Can you find Jordan High School on this? Take a minute and look. Where are we? And what I always do is I try to look for where this is Compton Creek, joins the LA River. You kind of go up, and where the LA River kind of bends and starts to bend back, that's where Jordan is. So where this dot is, that's Jordan. So we're right along the LA River. The stuff that drains off the grounds of Jordan High School go into the LA River, but not too far over. Like if you just go a couple miles over here, that stuff will make its way into San Gabriel River. And let's see, there's 500 miles of open channels, and then there's about 3,000 miles of underground. Now, so that's important for make sure it doesn't flood, but think about it. These are all areas that are collecting things. So this is a good example of just showing how difficult non-point pollution can be. It's just everywhere. Yeah, wherever you don't see, like in this area, wherever you see empty space, this would be places where they don't have houses. So like if you know the hills around Whittier, that's what this would be, the Whittier Hills. Griffith Park, GP, Verdugo Mountains right there. This is the Malibu Topanga forest or open preserve. That's all we can do. Keep polluting and just not live in places, right? And try to manage. But we can do a lot of positive things to manage. So I wanted to give you some firm examples of point sources and non-point sources. So let's run through a list. It's a lot, but hang in there. Just write some notes, maybe 2 of these, write it down so you have some to remember. Write down the ones you think you'll remember best. So wastewater discharge. Let's start with the first one, Hyperion Bay, or the Hyperion water reclamation. This is right in front of LAX, basically. So that beach in front of LAX, there's a giant water reclamation plant. And they release the treated wastewater about 2 miles off the coast. And it's underwater. Okay, so that water is really flushed in and picks up in the currents, and they really try to tune in to get to mix. And really, most of that water is very good. The wastewater discharge from treatment plants really isn't the big concern compared to just out of a random neighborhood. This is water that's been checked, tested, and cleaned. But it can introduce nutrients. They don't always get all the nutrients out, but it's usually pretty good. What's hard to get out would be like drugs that we take, different hormonal based drugs, psychoactive drugs. It's really tough to get out treated. It's really tough to remove from wastewater, and that can go out into the environment. Next, we got industrial discharge from factories along these big rivers or storm drains, or anywhere, because factories, if pollution washes off, it eventually goes into the ocean, into the LA River. So pollution enters from discharge pipes, and different chemicals can get into the wastewater and then go into the ocean. And just if it's hotter water, warmer water, that can be a pollutant too. And this would be a problem with power plants that are along. Power plants pull a lot of water, either fresh or salt, from the area. You'll usually see generation plants, natural gas or coal, near rivers, because they use the water to generate steam to power the turbines. So power plants that heated wastewater can damage the ecology. You think about a river needs to be cool. If it warms up a couple degrees, that's going to be a problem. Okay, there's a lot of sewer lines everywhere, and every once in a while they break and spill. I don't know why that keeps happening. I'll figure it out hopefully sometime. So a sewer line, example near Long Beach Harbor. This isn't common, but it has happened. They can trace it to a broken pipe, and you can have bacterial contamination. So we can get bacterial infection or bacterial contamination, from human waste. There's going to be a lot of E. coli and bad stuff in there. And the waste treatment plant is very good at getting that out of there. Here I have the last example, storm drain outfall at Bologna Creek. Oh no. Oh no. I'm going to have to write it up here. The way this is set up. Bologna Creek, that's also near LAX. Okay, that's right by Hyperion. Single visible outlet discharging runoff into the waterway. And that polluted water goes right into the creek or the ocean. Now, this is something that happened, I believe this is 2021. This is the Carson warehouse fire. What happened is this warehouse caught on fire. There's a lot of products in there that contain alcohol, and they spread water all over this to deal with this fire. It's a pretty serious fire. Nobody got hurt. But look, it left all this extra water with all the chemicals that got burned up, all the products that spilled. They went into this water, which guess what? This water is an open drainage channel. It's one part that's not buried but open, and this just went right to Dominguez Channel. And when all those cleaning products, the alcohol went in there, it killed a lot of the algae and the biological living things in there, and it created a lot of dead biological, dead organic matter. There we go. So all these living things, they're dead now, but it's organic matter. And that decayed very quickly. And when something goes fast like that, oftentimes it's anaerobic. Meaning no oxygen. And that can create a lot of hydrogen sulfide gas. And the gas level is like 230 times acceptable levels. And it smells like rotten eggs, basically. It's really nasty, and it can really make you sick. So a lot of people got sick in Carson, and they really didn't know, since this water went into the channel and it killed vegetation and living things a couple miles away. They didn't really connect it right away. But eventually a citizen group sued the company and won a pretty good settlement. Here's the warehouse, I believe. Look at that picture. Yeah. It's all of these things caught on fire. Whatever was in there, woo, it just caught on fire. And look, right there, that's the drainage channel. And all these chemicals, all that extra water from fighting the fire went into that drainage channel. And here it's buried, but it goes open right here, and then gets buried or covered again. And that went into the channel, and that created all that die-off, and it was nasty. So that's point stuff. Here's some non-point sources around our area. Oil and brake dust washed off all of our freeways is a perfect example. Comes from thousands of vehicles. You know how many cars are out there. And there's heavy metals in there, hydrocarbons. They get washed into the ocean. Fertilizer. I mentioned, fertilizer from lawns, golf courses, from all over the area, from Pasadena, Long Beach to the Valley, Sherman Oaks, whatever that is, it ends up in the LA River right outside our doorstep. So that's a huge amount of stuff just spread everywhere, and that adds nutrients that can contribute to algal blooms. And what that does, it grows, but then it dies right away, and then it all decays, and it's nasty. So it dies. You think, oh, it's just a bunch more grows at once, no big deal. But it dies, decays, and creates this nasty hydrogen sulfide gases. Here, pesticides from agricultural land. And also, remember, people can use those at their houses too. LA Basin, Inland Empire, many farms. It's just all over the place, diffuse, means spread out, and harms aquatic organisms, and can poison groundwater too. Pesticides, especially fertilizer. In the Midwest, they have a lot of trouble with poison groundwater because of all the fertilizer that can end up in that groundwater. And then trash, plastic litter, carry to run off. San Gabriel, LA River, any watershed. Countless streets, parking lots, and neighborhoods. Just everywhere. And we see debris. I can have a picture. Yeah, so I think this is from the LA River. After a storm, you see these massive buildup of just this trash and pollution sitting out there. All right, so here's a nice little concept explanation I thought worked well here. So a natural environment, this is what you see. When it rains, almost half of it evaporates because it kind of sits here and it can go back up. Whatever doesn't evaporate starts to infiltrate, okay, go into the ground. So you get shallow infiltration and deep. Half of it goes into the water, into the ground, and that's good. This is saved for later, right? It goes into the ground. You can pull it up later. And just about 10% runs off into rivers and streams, okay? Now compare that to an urban environment. Right away, you have a lot less evaporation because you see over half of it goes right into the rivers and the streams near the city. You don't have very much infiltration. You have a lot less recharge of groundwater supplies, which we rely on a lot here in Long Beach. And remember, this just goes to the ocean. So essentially that water is wasted. Plus, since you have all this runoff, there's all this pollution. All this non-point pollution from the city streets. And that's going into the ocean, or eventually into the ocean, into the rivers, and then going out to the ocean. So that's a concept. When we change our environment, we change how pollution affects that environment, how it ends up. We end up getting a lot more water pollution. Like in the Seattle area, Puget Sound suffers from a lot of water pollution because there's so much rain washing stuff off the streets into the Puget Sound water all the time. In some respects, we have less in LA because we just have less rain. We have less constant addition of pollutants into the Santa Monica Bay, although we have way more people. So we do end up having more pollution because of that. So those are some important things to understand about where pollution comes from. The thing you should really keep in mind. If you can figure out exactly where it came from, that's point pollution. If it's really hard to tell where it comes from, that's non-point pollution.